Hey there guys, and welcome to this video on pure substances and mixtures. Right, so what we're going to cover is the definition of a pure substance and of course of a mixture. You need to understand the melting and boiling point of a pure substance is very specific, and the melting and boiling point of a mixture is actually not. And you also need to be able to recall uses of mixtures and how their different properties affect their uses. Right, so let's jump straight in right now. Alright, so first of all, sorry, you can probably hear the washing machine in the background. I apologize for that, but of course I'm a busy guy. Right, pure substances. So a pure substance is just an element or a compound, right, or anything which is on its own and it's not mixed with any other substance, right? For example, pure water. Pure water is just H2O, right? And you have a look at this lovely diagram on the side. Okay, pure water is just H2O with literally nothing else with it. Okay, so H2O, the only molecules in that container in this case would be H2O, and that's what tells us that it's a pure substance. Okay, let's say for example we were to look at tap water. Well, tap water actually contains all sorts of mineral ions, right? Let's say like potassium and calcium ions and whatever else you're going to find in your tap water. Well, those are not chemically bound to water, right? And what I mean by that is water, H2O, is hydrogen and oxygen which are chemically bound together, which forms water. But if you've got potassium and calcium in there, those are separate from the water, but they're still in there, right? So they're not chemically bound, and this actually therefore would be a mixture, right? Tap water is a mixture, it is not a pure substance, because you have more than one substance. Alright, cool. So let's get rid of those and pretend that we have pure water. Okay, there we go. So you've only got H2O in there. Right? Pure substances have very specific melting and boiling points, and that's really important, right? We know the boiling and melting point of water because that's really how we define degrees Celsius, right? 0 degrees Celsius is the melting point of water. It's the temperature at which ice turns into water. But if we're to be picky, that is pure water, right? Pure water has a melting point of 0 degrees Celsius. If you had salt water or tap water, then the melting point, and by the way, that's the same as the freezing point, the melting point is going to be slightly different, okay? And we'll have a look at that in a second, right? The boiling temperature is also 100 degrees. It's exactly 100 degrees for pure water. It's not for mixtures containing water, right? So that leads us straight on to mixtures, right? So a mixture, as we've just seen, is a collection of more than one element or compound which are not chemically bound together, right? Just like the tap water example that we saw there. Now, mixtures freeze and boil or melt and boil over a range of temperatures, okay? A range of temperatures. Now, I can't stress enough that this word range is important. Okay, so rather than exactly at 0 degrees ice melting into water, if you had tap water, or even worse, if you had salt water or whatever it's going to be, then the melting temperature is going to be over a range of temperatures, not just at one specific temperature, right? So grit, which is used on roads in order to stop ice forming and to stop snow turning into ice and making the roads really dangerous, this utilizes this property. Okay, so for example, when you put those salts into water, it forms a mixture, right? Those salts don't bind chemically to water, it forms a mixture, right? And now you have a melting temperature, which is a range of temperatures rather than just a single temperature of 0 degrees. And if you see here, -10 to -30 degrees Celsius, okay, it actually alters the temperature and makes it a range. So basically, at any temperature from -30 to -10, that water could actually freeze into ice. And that depends on how much salt and what salt you have in that mixture. And so that's really useful because it means at freezing temperature, right? So normal freezing temperature of 0 degrees Celsius, water with grit in it doesn't freeze. That's the whole point, right? It doesn't freeze because adding the salt and turning it into a mixture has actually reduced its melting temperature. And so that is great. Okay, right, petrol is another example of a mixture, right? Petrol, as you should know, if you don't know about petrol, then please go and have a look at my organic chemistry videos. Petrol is a mixture. It contains a load of organic compounds. Those include alkanes and alkenes and various others, which you don't need to know, right? But it's a mixture. And so basically inside the mixture you have all these different carbon compounds, but those carbon compounds have different melting and boiling points. But overall, the mixture has a range of melting and boiling points, right? Or its melting and boiling point is a range of temperatures, to be more exact, right? Ignore that beeping if you can. So petrol as a whole boils between 60 and 100 degrees Celsius, right? It's not exactly 60, it's not exactly 70, etc., etc. It will boil over that range of temperatures, which is important because that's what happens with mixtures. All right, so one last point. If we had a substance and we don't know if it's pure or not, we can actually utilize this property. So if you were to take your substance and try and melt it or try and boil it, okay? If you see that it boils at a very, very specific temperature and it only boils at that specific temperature, then you have a pure substance. If, however, you see that boiling could occur at a range of temperatures, or melting could occur at a range of temperatures, then you have a mixture, right? And this actually allows us to distinguish whether a substance is pure or not. And so that is, of course, very useful. Okay, right, so I hope that made sense. I'm going to stop there. Hopefully now you know what a pure substance is and what a mixture is. You know the difference in terms of melting and boiling points. And also we covered a couple of examples, be that petrol and be that water, tap water, salt water, etc., etc. Okay, so as usual, thanks very much for watching. I do really appreciate it. I hope it did help. If you have any questions, pop them in the box below. But as usual, like and subscribe because that does help me. And I look forward to seeing you in the next video.